So let's have the next set of exercises for basic exercises on logarithmic functions or equations. And yesterday, I was able to give several of them already, but those that involve evaluation of logarithms. Now we're going to solve equations involving logarithms, or what we call logarithmic equations. And let's start with the most basic ones, like those that simply are given in terms of just x, as in this equation here. Uh, Either x is the input or x would be the base. And then we will discuss how to solve such basic logarithmic equations. So let's start with this item found in the exercises in the given in the module. So as I have discussed yesterday, all you have to do is convert this to exponential form. And to do so, let me just recall here. Suppose that you are given an equation in logarithmic form, then to convert it to exponential form, there are two ways. First, you note that the base is a, so that will also be the base for your exponential equation. And then you interchange the input and output, so that the output becomes the input and the input the output. So here the input is x, the output is y. So now y becomes the input and x the output. Okay, but the same base, exponential in form though. Or you could draw arrows in a counterclockwise fashion, okay, like that, and write as a to the y equals x. If that's preferable or more convenient for you, or rather easier for you to memorize or recall. So let's convert this one now to logarithmic form. So let me just do the second one, use the second one there to convert this. So that would be 0.01 raised to 3 over 4 equals x. There. That's the equivalent exponential form of the given equation there. And that means solving for x is equivalent to just evaluating this number here, which you can do so by using your calculator, but manually you will have to convert that to radical form. So that 4 denominator there gives us the index of the radical, with 3 as the exponent of the base 0.01 here. So we have, okay, let me first write 0.01 in exponential form again. That's 10 to the negative 2, by the way, raised to 3 over 4, and loss of exponents, you multiply. That becomes 10 to the negative 3 over 2. And then this is not exact, so you write it as 1 over 10 to the 3 halves, and then 1 over 10 square root of 10, or actually it's just the square root of 10 cubed. 3, the exponent, to the index square root, and that gives you 1 over 10 square root of 10, okay, as the value of x. Just give me a minute. Okay, next. So for x again, this time x is, did we do it right here? Okay, correct. So here, Wait. Same. Okay, same thing. So can you tell me what the value of x is? Just the same as the previous item. 1000. Okay, 331. Convert to exponential form. So square root of 11 to the 6 equals x, or that's 11 cubed, right? 11 to the 1/2. So 1/2 times 6. 11 cubed, 1331. So here in the first two problems, x is the input. Now, okay, let's have this one. Where x is not the input, rather the base of the logarithm there. So same principle applies, or method rather. You convert this to exponential form. And what do you have for x? Let's see. Anyone? Can you write it in exponential form? How does it look like in exponential form? You can send your answer to the chat box. Okay, x squared equals 1/8, correct? X squared then equals 1/8. And this is just a simple quadratic equation which has two solutions, namely plus minus square root of 1/8, which can be simplified as plus minus 1/2 square root of 2. But this one will be acceptable, and there's no need to rationalize this one. Of course, if required, that would be plus minus square root of 2/4. But this one will do. Okay, so however, we have to omit one of the solutions there, since the logarithm is defined only for positive bases. If you are given a function, or rather say an expression of this form, we do not have any meaning for logarithms if the base is negative, and x here is a base. Okay, only positive bases are actually allowed for logarithms. Actually, one is not allowed. Okay, let me explain. There's no meaning for this one. Example, logarithm of 2 base 1. If you studied the meaning or definition of logarithms, it means the power to which I should raise 1 to get 2. Okay, let me give simple illustration. What is this? Anyone? What is that? 6. Well, how did you get 6? It's 6, 2, 4, 8, 16, 32. It's 5. It's the number, the exponent, which I should raise the base to get this input value. That's 5. That's the meaning of logarithms. It's the inverse of the exponential. Okay, instead of 2 being raised to 5 and then getting the output 32, 32 now is the input to get the output, which is the exponent. So how about this one? What should I raise 1 to get 2? That's impossible. It's impossible to get such an exponent, because 1 raised to any exponent is always itself. That's why we avoid 1 when we consider logarithmic functions or expressions. Okay, so in this one here, x cannot be negative and x cannot be 1. So that means we have to disregard that negative value. So x equals just 1 over 2 squared. Okay, so next, try this one out. It requires a use of one of the properties, or this can be manipulated, so you won't have to use that. Okay, I'll give you some time. Okay, one property of logarithms is this. Okay, we have this one. Logarithm. Okay, I think I should defer a use of this property so as not to mix up a lot of things here and confuse you. Okay, so anyway, without having to use a property of logarithms, we can divide everything by 2 first to get this equivalent equation. Okay, dividing by 2, get 1 over 6. And then we do the usual thing, convert to exponential form. So x to the 1 over 6 of this. Then equal to cube root of 49, or just 49 to the 1/3. So that when I raise both to 6, we immediately see that we just have to divide, or rather multiply. So to get x, we raise everything to 6 so that it becomes x on the left-hand side. So we raise this to 6. We also raise the other to 6. And then we multiply the exponents, loss of exponents yan. 6 times 1 over 6 is 1. And then 6 times 1/3 is 2. So x is 49 squared, which is, get my calculator. Wait. 2,401. Okay. So is there any question so far? Okay, next. If you studied the video I uploaded yesterday, you may already know how to do this, or if you read the material, studied in advance. Okay, there's some property that is needed to simplify the expression on the left. Anyone can tell me what that property is, or just quote that property stated in words? Anyone? Oh, wait, maybe I muted it. Okay, no one can answer. How does the left hand side simplify na lang? Can you simplify the left hand side there? 10 raised to the logarithm of x squared minus 6. What base is that logarithm there? If the base is not written, is understood to be base, what? 10. Okay, we call that again, as I have mentioned yesterday, common base, as opposed to natural base E, as discussed last Wednesday. Okay, so we have this actually identity that the logarithm, well, we know that the logarithm and the exponential are inverse operations, so they cancel each other out. In other words, if I raise a to its logarithm, or rather the logarithm of x base a, I get back to x. This is like a composition of two functions. Remember, f of g of x. And inverses have the property that they undo each other, meaning we get back to the input value x, either way around. Okay, so if I apply one function to the other, I sort of undo what the first function did. So I get back to the input value x. And there, in this identity here, we see that we first, okay, we have the input x. We first get its logarithm base a, and then we take the exponential base a to that. And since they are inverse operations, we get back to x. Similarly, I've repeated this several times in the videos. If we first take the exponent a to the exponent x, and then take the logarithm of that to base a also, we get back to x. So that expression on the left becomes what? Anyone? How do you simplify the expression on the left? Can you type your answer? X squared minus 6. Okay, so let me just give simpler examples. What is 10 log pi? Anyone? 10 to the log pi. Pi, yes, it's pi. Whatever that number there is. 10 to the log 2 is 2, because this is base 10, log 10, base 10, and exponential base 10 cancel out. It's true to any base, like 3 to the log base 3 of, say, square root of 2. This is base 3 exponential, this logarithm base 3. So we get back to the input square root of 2. How about this one? E to the ln 2. Okay, 2. This is just base e, remember? Logarithm base e. So they cancel each other out. Get back to 2. So again, yes, that's correct. We have the left-hand side here just equal to the input x squared minus 6. And this just is actually just some quadratic equation. X squared equals 9. So there are two possible values, plus minus 3. Now you have to be aware that logarithms are also not defined for all real numbers. What's the domain of the logarithmic function, log x? Log x, if this is your function, its domain is, anyone? Set of all positive real numbers, which we denote by r plus, meaning all x greater than 0. So that means that the logarithm is not defined for negative values. Try your calculator, get it. evaluate, for instance, use base 10, logarithm of -1, it will give you an error. Actually, it has a complex value, but that's beyond the scope of our course. But you can also try log 0. Logarithm of 0 is also not defined. So the domain of the logarithmic function, just take note of that, is the set of all positive real numbers. So that means even though we got several possible solutions here, we have to check if they are in the domain. Okay, will the logarithm be defined? So although here it will be of no problem if we plug in either plus or -3, we do get a positive inside. Okay, 9 minus 6. So walang problema. Pero halimbawa, okay, just to make my point clear. Halimbawa, ito yung sinagot mo, no? Ito, halimbawa. Okay, sige. All right, let me just give you this function, and then let me point out that this is not defined for any real value. Now, suppose I plug in x equals -5. Suppose this is the solution that we got. Okay, theoretically lang to. Suppose we solve an equation, and one of the solutions we got was x equals -5, and it seems to satisfy the equation. But the problem is, if you plug it into one of the terms in the equation, let's say which has this term, there would be a problem, since if you plug in x equals -5, you will get a negative inside the logarithm. Later on, I will give examples, medyo parang later on pa talaga yon, ano? Where you have to check if all the solutions you've obtained are in the domain. But when you're solving exponential equations, walang problema. A to the x, you can use any real number. X can be positive, can be negative, can be 0. Walang problema kapag exponential equation, no? Like 2 to the x equals 1, diba? 1/2, and you solve for x is -1. There's no problem. If you put -1 here, it will be defined, but not for logarithmic equations. Okay, next. Okay, try this one. Okay, correct. So it's just quadratic. Okay, so the left-hand side just becomes, so ln and e cancel out, right? You first take it to raise it to, or base e to that, and you take the ln of that, get back to that. This is always an identity. Ln e to the x is always x. You raise e to x, and then you take the ln afterwards, you get back to x. And you can just solve quadratic equation there. X plus 5 x minus 4. Teka, tama ba? X squared plus x equals negative 20, x squared plus x plus 20 equals 0. So we need 4 and 5. Hindi yata sakto. Tama kasi dapat negative 20 siya. So you will have to resort to the quadratic formula. Negative b plus minus square root of b squared minus 4ac. So it's not a real number. Yes, imaginary siya. Of course, you have to show this. Nagkamali siguro ito, baka typo error ito. Dapat positive 20. Okay. Kung ginawa nating positive 20 yan, may sagot tayo, no? Factorable siya. It will become x squared plus x equals 20. And we have yan. Equals 0 yan. So negative 5 tsaka 4. Okay. Any questions so far? So try this one out. Okay, somebody got 7. So how does the left hand simplify? Just the input. And e to the ln of x is x. Don't forget this. The input is x. Get it, the logarithm of it, base e. Then you raise it. You raise e to that. You get back x. Okay. So cross multiply. X is 7. Okay. Try this one. There are two possible answers. Yes, x equals 1, but there's another one. Okay, that's correct. 1 and e. So how did you get e, Mr. K? explain? Mute your mic. Okay, you used a substitution. That's also okay. Yes. Right. Okay, that's by substitution. We can do that. So let y equals ln x. Finish any other variable. So in terms of y, it becomes y squared minus y equals 0. And this is quadratic in y, which you have to factor out, giving you two possible cases: y equals 0, y equals 1, and y is ln x. Okay, y equals 0 is this one, and y equals 1. And then how do you get the answers given, 1 and e? Don't forget, this is just base e, okay? So if you want to see it this way, you convert this to exponential form, okay? E to the 0 equals x. Or that's just 1. And then for this one, same thing. E to the 1 equals x. Or e. Okay? So you get two possible valid answers. Or sometimes if you want to do it directly, you can just factor out ln x. Okay? And you equate each factor to 0. Pareho din ang makukuha. So yun yung case 1 natin kanina. And ito naman yung case 2 kanina. ln x equals 1. Pero yun, ang maganda sa substitution, kita mo agad ang gagawin. Makita mo quadratic lang din siya. Okay, next. Last one for today. Okay, correct? Mr. Diaz and Ms. Batol. So you just have to convert to exponential form, right? Remember this. Just raise a to y, and equate that to x. And you do it several times. So let's do it. 5x to 0 equals the one inside. Okay. This is the one inside. It's 5 to the 0. Again, 5 to the 0 equals this. The whole thing inside there. And this is just 1. Then again, 5 to the 1 equals this. Then x squared equals 9, x equals plus minus 3. Okay, so do you have any question? So if there's none, that's it for today.